Next in our program is Dr. Jonathan Whitty, who grew up in the Midwest and spent his early adult life in the greater Chicago area. He moved to Everett in 1982 and practiced medicine there for 30 years. As a retired physician, Jon is particularly concerned about the health impacts caused by climate change and has spent much of his free time working on this issue. He's an active member of several climate groups, including Washington Physicians for Social Responsibility, the Climate Reality Project, Ever 350, the Elders for Climate Justice. He loves nature and spending time outdoors and is particularly excited about approaching snowboarding season. Welcome, Jon.
Thank you, Kate. And I'd also like to thank the League for inviting me to speak here tonight and for hosting this event. As you just heard from Dr. Gammon, we are dealing with a climate emergency. And what I'd like to do in the next 20 minutes or so is to describe to you just how this emergency impacts our health. As you know, we have a problem. This photograph was taken from Apollo 8 command module on Christmas Eve, 1968, and showed us for the first time just how small and fragile the planet we call home actually is. As you've just heard, global temperatures have risen dramatically in recent decades, primarily due to the burning of fossil fuels. And scientists predict that there's a 70% chance that this year will be the hottest year ever. And the impacts of this are already being felt. We're seeing more heat waves, more severe storms and floods, more droughts, more wildfires, and rising sea levels. And climate change has also created a medical emergency. In fact, the World Health Organization considers climate change to be the greatest threat to global health of the 21st century. And as a physician and a member of Washington Physicians for Social Responsibility, I care deeply about issues that affect our health. Unfortunately, climate change has become one of them. And the human cost of climate change is unacceptable. We will examine the cost from two different perspectives. We will look at how climate change directly impacts our health, but we must also view these impacts through the lens of social justice, because climate change does not affect everyone equally. Still, at the core, it's about people, our kids, our families, and really everyone. Climate change impacts our health in many ways, which can be complex and are often interrelated, and we'll take a look at each of these. First, the most obvious impact is the direct effect caused by heat stress. When our bodies begin to overheat, they become dehydrated and we start to experience muscle pains and heat cramps. As our body temperature continues to rise, we develop heat exhaustion. Finally, if unchecked, we experience heat stroke, which can be life-threatening. Each year, extreme heat events cause more deaths in the United States than all other extreme weather events combined. And who is most vulnerable to heat? The elderly, along with infants and children, those with pre-existing medical conditions, particularly cardiac and respiratory problems, agricultural workers and others who work outdoors, and also low-income communities and communities of color who may live in urban heat islands and not have access to adequate means of cooling. Now let's consider extreme weather events. These include extreme temperatures like we just mentioned, but also include other things like droughts, fires, floods, mudslides, and storms, all of which, as you can see, have increased dramatically in recent decades. Let's first look at storms. 93% of all the extra heat that is trapped in our atmosphere goes into our oceans. And as temperatures increase, oceans evaporate more moisture into the sky, and all that moisture must end up somewhere. So the downpours get bigger and storms more powerful. Take hurricanes, for example. As you just heard, in recent years, climate change has caused them to become more frequent and more severe. One very powerful and devastating storm was Hurricane Harvey in 2017. It was the perfect storm. That year, the water in the Gulf of Mexico was particularly warm, which allowed Harvey to intensify very rapidly. Harvey intensified from a tropical depression into a Category 4 hurricane in just 2 days. Also, the combination of unusually warm water in the Gulf and hot air temperature caused much greater evaporation of water, which resulted in a particularly heavy rainfall. And finally, a wavier jet stream caused Harvey to stall in place for more than 2 days. As a result, Netherland, Texas received a record-breaking 8 feet of rain, or 5 feet of rain rather. And as you would predict, this led to massive flooding. Now, to make matters worse, this flooding occurred in one of the world's the largest and most dense petrochemical regions. It caused more than 100 toxic chemical releases, and many of these affected low-income and minority communities, which are often located near industrial areas. This is another example of the social inequity of climate change. You may also recall Hurricane Maria that same year, which devastated Puerto Rico. Although the death toll from the initial impact of the storm was listed at 64, the final death toll reached nearly 3,000. And this was caused by a failed disaster relief effort and resulted in long-term power outages, poor sanitation, inadequate clean water and food, as well as lack of access to medical care. And many of those deaths occurred in Puerto Rico's poorest communities. A significant number of those deaths were caused by infections, which brings us to the next health impact of climate change, infectious disease. Increased temperatures and more frequent flooding increase the risk. Climate change is disrupting natural ecosystems in a way that is making life actually better for infectious diseases. And climate change increases the risk of many waterborne infectious diseases, many of which are shown on the slide here. More than 2/3 of waterborne infectious disease outbreaks in the US have been preceded by extreme precipitation events. And climate change has also expanded the habitat of many vectors which carry and transmit diseases to humans. Some examples of these vectors are shown on this slide. And here are some examples of tropical diseases that are on the move. Many of these diseases are carried by mosquitoes and have already reached the United States. In the US, the number of mosquito-borne infections has increased nearly tenfold between 2004 and 2016, and the number of tick-borne diseases has more than doubled. Higher water temperatures also increase the frequency of toxic algae blooms. And here's an example of one that occurred in 2015, which affected the entire West Coast and shut down many fisheries due to high levels of neurotoxins. And we're also seeing the emergence of new infectious diseases caused by climate change and humans' expansion into Earth's remaining wild places. An average of 5 new infectious diseases occur each year. And 75% of all of these new diseases are zoonotic, meaning that they are transmitted from animals to humans. And I'm sure you're all too familiar with one of these new diseases. COVID-19, which as of Monday had infected over 40 million people worldwide and over 8 million here in the US. As you can see in the bottom right of this screen, the rate of new infections continues to rise steeply and is now up to almost 500,000 new cases each day. Worldwide, it has killed over 1 million people, with over 220,000 deaths occurring here in the United States. Unfortunately, deaths continue to progressively rise, and we are projected to reach as high as 400,000 by mid-January. As you can see from this graph, COVID-19 is not an equal opportunity player. It disproportionately affects certain ethnic groups. For example, the death rate for Black Americans is twice as high compared to white Americans. In New Mexico, the indigenous mortality rate is 7 times higher than the rate of all other groups. Now, the same extra heat that evaporates more water from the ocean, causing bigger downpours and floods, pulls moisture even more quickly from the soil, causing longer and deeper droughts. This leads to other problems such as wildfires, which have become more frequent and more severe. This year, as you've heard, has become particularly devastating. So far, just in California, Oregon, and Washington alone, over 7 million acres of forest have been burned. 42 people at least have died, and over 13,000 structures have been destroyed. This photo was taken 2 years ago in Colorado. And Colorado is currently once again being ravaged by wildfires. But the actual impact from wildfires isn't limited only to the direct damage caused by their flames. Because of their massive size, they spew toxic smoke particles into the atmosphere, which in many cases travels across the globe, ultimately ending up in the lungs of people living thousands of miles away. And this is a recent satellite photo showing just how massive the amount of this dense smoke these fires can generate. Most of you probably experienced firsthand the choking effects of this smoke. Air quality along the West Coast was the worst on record, and in some places was in the very unhealthy and even hazardous range. But it's not only wildfires that cause air pollution. In fact, most often air pollution in the United States comes from the burning of fossil fuels used for transportation, to heat our homes, to supply our energy grid, and for industrial purposes. And carbon dioxide and other pollutants are emitted together, and it's some of these other pollutants, like small particulate matter and ground level ozone, that have the most devastating health impacts. There are direct links between air pollution and many human diseases, including asthma in children, acute and chronic respiratory disease in adults, cardiovascular deaths, type 2 diabetes, and several neurologic diseases, including Alzheimer's. Nationwide, it's estimated that air pollution causes 150,000 new cases of diabetes each year. And here in Washington State, air pollution causes 1,100 deaths each year from heart attacks alone. And air pollution is widespread in the United States. In fact, more than 40% of Americans live in counties that don't meet EPA air quality standards. And we're not immune to this here in the Pacific Northwest. In fact, in 2019, the American Lung Association ranked the Seattle metropolitan area as having the 9th worst air quality in the entire nation. And these regions often tend to be congregated near transportation corridors and around industrial areas, places that often have a high proportion of low-income communities and communities of color. For this reason, African Americans overall are 3 times as likely to die from particulate air pollution as the overall population. There's also a link between the susceptibility to COVID-19 infections and exposure to air pollution. This is likely one of the reasons why the death rate for COVID-19 infections is higher for Black and Brown Americans, and also in indigenous groups. Worldwide, air pollution kills approximately 9 million people each year. About half of these deaths are caused by ambient air pollution, and the other half due to indoor air pollution, particularly in underdeveloped countries. This is primarily caused by using wood burning and kerosene stoves used for cooking and heating. It should be noted, however, that even here in the United States, the incidence of asthma in children is 42% higher in homes that use gas stoves for cooking. Here's a world map showing the distribution of deaths from ambient air pollution. Here in the United States, it's estimated to cause approximately 50,000 deaths each year. And as you can see, in Asia, it's even much worse. In India, for example, it's estimated to cause 1.25 million people. 1.25 million people died in 2017 from the effects of air pollution, which was 13% of all their deaths. And while we're talking about respiratory impacts, let's take a look at allergies. Climate change is making allergies worse. Warming is causing the ragweed season to start earlier and to last longer. Plus, pollen production increases as carbon dioxide levels rise. This illustration shows the number of days that the ragweed pollen season lengthened between 1995 and 2011. And these numbers are no doubt much higher today since allergy seasons have progressively worsened. Mold and pollen are the primary cause of allergic rhinitis, which we commonly refer to as hay fever. Allergies can also trigger flare-ups of asthma and other significant respiratory diseases, which can be life-threatening. Now let's take a look at food and water, and we'll examine these together because their impacts often go hand in hand. Rising temperatures combined with more frequent droughts and floods decrease crop yields. For each degree Celsius rise in temperature, crop production goes down. For corn, this is 7.4%, for wheat 6%, and for rice and soy, slightly more than 3% each. And together, these 4 crops account for 2/3 of all human caloric intake. But not only this, high carbon dioxide levels decrease the nutritional content of crops, so the food that is produced is less nutritious. Protein is reduced in crops like rice, wheat, and soybeans, and minerals including zinc, iron, copper, magnesium, and calcium could be reduced by as much as 5 to 10%. Droughts are one of the most important causes of famine and malnutrition, and water scarcity already affects more than 40% of the world's population. And we won't be immune here in the United States. At the current rate of groundwater depletion, 35% of the southern high plains will be unable to support irrigation by 2040. One stark example of the effects of drought is in Chennai, India's 6th largest city, where its reservoirs have essentially disappeared, and all that remains is a dry lake bed. Now, while the affluent can afford to have water trucked in from elsewhere, the poor are left to fend for themselves. On the African continent, 5.4 million Somalians are facing severe food shortages due to ongoing drought. In the Middle East, in places like Syria, prolonged drought has transformed farmland into desert. And when people don't have enough to eat, their natural response is to flee and try to find some place where they can at least survive. And this frequently results in political and social unrest. Closer to home, climate refugees have fled the dry corridor of Central America and have shown up at our southern border. You may recall the heartbreaking images showing the detention facilities where they were held. The main reason people are moving is because they don't have anything to eat. We are seeing tremendous climate instability that is radically changing food scarcity in the region. But you don't have to take the word of an academic or a humanitarian for this. Here's what the United States Department of Defense had to say about this back in 2014. Climate change will lead to food and water shortages, pandemic disease, disputes over refugees and resources, and destruction by natural disasters in regions across the globe. By the end of the century, it's estimated that the world could see up to 1 billion climate migrants. But this influx won't be limited to just our nation's borders or somewhere else across the globe. Millions of Americans living in the low-lying coastal southeast will experience rising sea levels, as you just heard, and will likely move inward, fleeing to higher ground. Millions of others in the southwest will move northward to escape the sweltering heat. Others who live in the Midwest Farm Belt, when faced with worsening droughts, will move elsewhere, seeking greener pastures. And many people in California who have endured repeated and worsening wildfire seasons will likely pick up and move also. So here in the Pacific Northwest, we may need to be prepared for an onslaught of migration. Now, climate change is also affecting our mental health. All of the multiple impacts that we've just been talking about have taken a huge emotional toll. We've already seen a significant rise in levels of anxiety, PTSD, depression, and despair. So yes, we do have a problem, but I don't want to leave you here with just doom and gloom. I'd also like to give you some good news. We have solutions at hand. For example, we've made tremendous strides in developing clean energy. Wind energy capacity has grown exponentially in recent years, and the cost of onshore wind has fallen dramatically. Globally, wind could supply electricity consumption 40 times over. And each hour, enough solar energy reaches the Earth to supply all the world's energy needs for an entire year. Worldwide, solar panel installations have also skyrocketed. And the cost of solar panels has plummeted. The cost of clean energy, both wind and solar, is now on par with, and in many places is cheaper than energy from fossil fuels. But what happens when the wind doesn't blow and the sun doesn't shine? Well, that brings up the issue of energy storage or batteries. Now, these can be either on the industrial scale, like commercial utilities, or on the personal scale, like electric vehicles or EVs. Over the last 10 years, battery storage capacity has only gradually increased. However, with recent advances in technology and production, it's projected to increase dramatically over the next 2 decades. And the price of batteries has continued to fall. According to Bloomberg, solar plus batteries is set to begin a dramatic transformation of human civilization. And one of the benefits of advances in battery storage is electric vehicles. There's been a continued increase in EVs on the road over the last 10 years. And this trend will undoubtedly accelerate as EVs become cheaper to buy, use, and maintain compared to conventional vehicles. While the cost of owning even fuel-efficient gas-powered cars will continue to increase, as shown here, the cost of EVs is projected to steadily decrease and will reach parity with gas-powered cars within the next few years, and then will become cheaper. In fact, General Motors believes the future is all electric. And what has happened to coal consumption? In the US, it has dropped dramatically over the last decade. Importantly, this shift away from coal is estimated to have saved over 26,000 lives in the United States. So hopefully, sometime in the not too distant future, the only place that you'll be able to find coal is in a coal museum, like the one here in Kentucky. It's interesting, if not a bit ironic, that this actual museum installed solar panels on its roof to save on energy costs. And yes, there's more good news for clean energy. Over 240 global companies have made the commitment to go 100% renewable. So far, I've been talking primarily about technical advances in the fight against climate change. However, I'm equally, if not more excited by fairly non-technical things that are being done in the field of agriculture, particularly regenerative agriculture. Agriculture and food systems are the key to global climate change responses, according to the Intergovernmental Panel on Climate Change. Conventional farm practices degrade the soil, robbing it of its biodiversity and also depleting its nutrients, water, and carbon. Regenerative farming, on the other hand, regenerates the soil using innovative practices like no-till or low-till soil preparation, and it avoids using pesticides and synthetic fertilizers, and instead uses compost and plants cover crops and perennial crops, and also much, much more. Regenerative agriculture also provides a key way to significantly put carbon back into the soil and has the potential to reduce atmospheric carbon dioxide levels by an astounding 156 parts per million by the end of the century. Regenerative agriculture is not only good for the soil and the environment, it is also good for our health. If you want to learn more about this, here's a plug for a recent Netflix documentary that goes into much more detail. So grab your pen. It's called Kiss the Ground, narrated by Woody Harrelson. I found it to be extremely informative, inspiring, and also entertaining. So again, that's Kiss the Ground on Netflix. In the 2015 Paris Climate Agreement, every nation in the world agreed to work together to achieve net zero greenhouse gas emissions by mid-century. The US cannot legally withdraw until the day after the 2020 presidential election, just 2 weeks from today. And I'd like to close with a quote that I find really encouraging. We expect innovation in global markets rather than politics to continue to be the primary driver for the growth in low carbon technology. In our view, prices for batteries and solar panels will continue to drop, and global market share gains will continue for wind, solar, electric vehicles, and LEDs, regardless of who occupies the White House. That's from Goldman Sachs. But I don't have to remind this group that it's not unimportant who occupies the White House or other elected offices. I urge you to join those who are using their choices, their voices, and particularly their votes to fight for our future, our community, and our world, because our world depends on it. Thank you, and I'd like to now turn things back over to Kate.
Thank you, Dr. Witte.